Hi there, everyone. This is Neil with just a brief webcast on how to automate builds and tests and other functions behind your GitHub repository. So it's a great thing. It makes life a lot easier to collaborate on code and to version it and to track it and so on, and to have branches and merges and so on in Git and GitHub. This is the way we need to work. It's just an important sort of tool that helps keep us organized and gives us a way to have some order to our collaborations and to tracking our progress over time. But what's important to know is that if I have code of an application, and we'll kind of dive into this one in a second, I want to be able to add to it over time. I want to be able to deploy it or to build or to test against it. And I can do that. I can do that by hand on my local workstation, but it would be fantastic if I could actually automate that and have certain safeguards so that maybe my code gets tested automatically, and if it fails, it could notify me of that. Maybe it could build automatically and push to some place, or often in our world of systems and platforms, we will have our code that gets pushed back to GitHub. We'll have it test automatically, we'll have it build automatically, and we'll even have it deploy automatically. So it'll go out onto the machines, on a rolling basis without any human intervention. And it'll actually let us know if it fails, and it'll actually roll back gracefully if it does fail, so that nothing really goes down. The point is that it can sort of, if it's not working, it should walk backwards and walk everything back. So this little video is on how to set up a really basic GitHub action for a repository in GitHub. And in this case, I have a Docker project that I've been working on. So let's flip over to VS Code. You can see this is written in Flask, which is another Python framework for writing APIs and web applications. It's a lot like Fast API, just a little older and thicker in some ways. But this does basically the same sorts of things that our Fast API project was doing. So that's the app file. We've got a Docker file here, not very complicated. A couple markdown pages. We have an Nginx web server configuration, which is just sort of static and just needs to get injected. A requirements.txt file. And then what we need to, and so I should say, all of this is running fine. I can build it locally. I can test it. It works great. I could build a container and push it up to GitHub, to Docker registry, Docker hub, just fine. But I don't want to do that anymore because, remember, professionally, I want to be lazy about that. So, think about it. In the future, probably all I'm going to do is iterate on this app.py file, and I'm going to add more functionality behind my endpoints or additional endpoints, and so on. Maybe every now and then I might add a new package to my requirements file. But that's pretty much it. I'm going to just iterate on those things and slowly make this more and more robust. So to set up an automatic build, I create a hidden folder called .github, and inside of that, another folder called workflows. And within there, I set up a YAML file. And we'll just take a look at this YAML file. But I want you to know the only switch I need to turn on to set up a GitHub Actions is the mere presence of these folders with a YAML file that's well configured inside of here. So there's no other switch to do it, and we'll see that from the GitHub page in a moment. So let's explain this file and just walk through it piece by piece. First, I give my workflow a name, Docker build CI, so that means continuous integration, CI. I can set up a trigger for when this build process should occur. So it will occur on a push, and only a push, for this specific branch, the master branch. So if I set up a dev branch, for instance, and I push back, this will not get triggered. If I were to do a pull request or a merge or an issue or something like that, this trigger will not get issued because it's not a push. So this is a pretty nice condition. And then from here, I can just set up jobs, and I have two jobs. I have a build job and I have a publish job. And in this case, these two jobs are pretty much identical, and so I'll explain each one. First, in order to use Docker and to sort of set up a Docker build and a Docker login, I have to use these two sort of pre-built actions, set up QEMU and set up Docker build X. I don't even know the guts of what goes on in there, nor do I want to know. This is just something recommended from Docker, and this makes it possible. The third step is very important. It's going to log into Docker Hub as me. And so all of this is really important. It's, again, relying on somebody else's action that they defined. And it's going to use two secrets. And secrets are a way that we can pass, pretty privileged information into a running environment without, exposing those credentials to other people. So one secret is called Docker Hub username, and the other secret is called Docker Hub token. And when you set up a Docker Hub account, you set up a username and password, but you can also set up a token for yourself, which is like a really long, ugly password, and you could have a couple of them at a time. And this is a nice way to pass, good, strong credentials in. The fourth step is a build and push. So it's going to log in as me in the previous step, and then it's going to build a container and push it. And it's going to push it to this organization, to this container image name, and with this tag. What's nice is that this tag could actually be different based upon my branch. Maybe I could do this on multiple branches, and if it was dev or something like that, I could actually maybe tag this as dev. So this, I can use logic in here and variables and so on. And then the final step 5, is sort of cleaning up everything and echoing back what I get. So that's the one build process. And then the second one is a publish process, exactly the same, but it's going to push to the GitHub container registry, which is a different place to store container images. Same functionality, just a different place. So step 3 of that one is going to be logging in to the GHCR. It's going to log in as me, and so you get a GitHub username and password, but you can also set up a personal access token, a PAT. Then it's going to build and push, and in this case, it's going to push to the GitHub container registry, ghcr.io, then my organization name, then my container image name, and then my tag. And then it cleans up at the end. So that's it. Notice there's no dependencies of these two jobs. They actually run in parallel, the build and the publish. And I'll point that out in a second, what that means exactly. But let's go ahead and modify something here a little bit. Let's say, hi there, everybody. It's a bright, sunny day outside. And we'll save that. Aha, I need some double quotes here, because my little quote inside of it's is going to throw things off. So great, we'll save that. I'm going to hop into development, Flask container, and I'm going to see git status. There's the page that I've changed. By the way, I just like the command line for doing my GitHub work. I could do it over here if I wanted from within VS Code. I'm just used to using the straight up command line. So I'm just going to say git add, git commit, testing with a build, and then git push origin master. Okay, so that's pushing. That has pushed. And now if I come back to my repository in GitHub, I need to set up a couple of things. First of all, I need to go into the settings and set up my secrets. And so you go to settings for the repository itself, go down to secrets, and you'll see here is my GHCR pat and my GHCR username. Now, even I can't open these up and read them. I could remove them if I wanted. I could update the values of them, but I could never go get the values that I put in here. They're secret. They're gone. They're saved and secured forever. So if I wanted to create a new secret, I could just do it here. I could name it, it could be Neil with a value of McGee. It's just a key pair, and there it would be stored. There's also organizational secrets, which are at sort of a higher level, and that means just different repositories. They can all rely on these same values. So I have a Docker Hub token and username over here. So once I've saved these, that means my my action can consume them. So if I go here to actions, you'll see here is the Docker build CI for this repository, and you can see here my build that I triggered is already going. And so if I want to see details of that, first of all, I can see it's the build number 25 from this commit posted by N McGee on branch master, happened a minute ago. I could view it, I could cancel it and so on, but I can just click into it if I want. And here are my two jobs. Job 1, job 2. Now, what's an option, if you ever want, is you can make you can make these dependent upon each other. So maybe if job 1 succeeds, then it triggers job 2. Or if actually more commonly for us, we'll use it this way, so that if job 1 fails, then run job 2, which might be like a notification, hey, send me a note, an email or an SMS or something like that it failed. But in this case, we're just running these in complete parallel. It's sort of like a little race between these two jobs. They're both doing the same exact thing. And if we want to see what they're doing, that one just finished and the other one just finished. You can see here are my steps. It set up the QEMU and the Docker build, logged into Docker Hub. There's the success, build and push. It went, you can see this scroll is really, really long to go through everything of a normal build. And then that succeeded. It has an image digest with a SHA code. It posted it and pushed it, and so on. So this is nice. I can come back out to my summary and I can see the process here. It lets me know that I had success. Here's my duration and so on. And then I can actually go back out to actions and I can see, okay, this one succeeded in line with all the other ones. And what's great is that now my container has been built and pushed to these two registries without me having to do a single thing. Only for purposes of debugging do I really ever hop into this page to see what's happened. I know that from the moment I push back, 2 or 3 minutes later, my container is going to be built. And then if I'm using infrastructure, if I'm pushing this out to servers, within 3 or 4 minutes total, my container might be deployed already on a farm of servers, so that I don't have to manually take that image and pull it out and so on. So this is the sort of automation you can do. You could automate a test, so unit tests against your code. You could automate a test and build with sort of dependent logic and so on. You could even create pull requests and so on. So you could, if you were working in a team with a pretty elaborate workflow, and you've worked on your little portion of it, you could have a build process or an automated action that would test your segment of the code. If it passes, then it might submit a PR on your behalf and say, okay, hey, I'm checking in my code. It all works fine. Here's a PR, so you can merge it into another branch. So these are all really powerful options that just remove a lot of tedious manual steps. Thought you'd enjoy seeing that and just knowing about these options for the future. Thanks.